the last lecture students we have discussed about the working of an low flow boiler. Here we are going to discuss how efficiency can be increased using an Velox boiler. Okay. So what is the main theme we are going to study here is by using a less surface we are going to increase the evaporation rate. That is the steam formation. Okay. Now what are the components as we discussed in the previous lecture series? What is the purpose of economizer? What is the purpose of economizer? To heat the inlet water. Okay. Next, what is the purpose of a superheater?
Reheat the
reheat the steam. Okay. So that is the purpose of an. Now here we are going with an descending approach that we are having a small case study how we are increasing the steam formation in a Velox boiler. Okay. So here initially this is a combustion chamber. This is a combustion chamber, and here this is a water circulating pump, and here this is a steam separator, and here feed water, exhaust economizer, okay, gas turbine, valve, prime mover, steam in, all these circuits are. Now we will have a starter flow from the initially. So initially water is available in the feed water tank. Where water is in the feed water tank. From the feed water tank, by using a feed pump, water is supplied to the economizer. Okay, first water is supplied to the economizer. What is the purpose of economizer? The water before going to the combustion chamber, we are preheating the water. Okay, so here what happens? So the waste heat is going outside is utilized for heating the water. So from the economizer, what happens? Comes to a steam separator. Comes to a steam separator and comes to the combustion chamber. So in the combustion chamber, what happens? The water is getting heated. Okay, here. So which is coming downwards, all the water is coming here, and the water is getting, again water is circulated to the combustion chamber. So when the water is circulated inside the combustion chamber, what happens? It absorbs more amount of heat, and then steam comes to the topmost part, and then the steam is coming outside. The steam is coming here. What is this called? Superheater. So the waste heat which is coming outside heats the steam which is coming inside. So normally the temperature of the steam which is can be increased in the superheater. So this superheated steam goes to the turbine. Okay, can you understand now? So now see the line, what happens? Water is coming here, it is getting heated in the economizer, and is coming here, and is coming to the steam separator, is going to the combustion chamber. Water is getting heated and converted into steam. Okay, this steam what happens? It goes here, and again the steam is reheated and goes to the prime. Now come to my question. Here, where is the prime initially the heating takes place? In the, no, what I am asking is, first initially the heating combustion takes place, heating in the combustion chamber. Here only heating takes place. Okay, but the waste heat is going outside. Okay, the waste heat is going outside used to heat the steam, and after completing the process, the waste heat is going outside is used to heat the water. Can you understand now? Two things we are making. One, the fluid gas is heating the incoming steam, and after completing the gases which is the steam is coming. Now, what is the purpose of this compressed air and the fuel tank? In case of the previous condition, what we have made is we have used the fuel to burn. Okay. Now what happens is, this is a fuel tank. We are using a pump to supply the fuel to the combustion chamber, and also compressed air is going to this combustion chamber. Okay. So here, can you tell me What is the difference of the compressed air with the combustion chamber? What is the need for compressed air? Why normal air can be given? Why just the normal air can be given to this combustion chamber from the atmosphere? Why we are going for compressed air? Very good. To have a quick burn. Second one, to produce extra heat. So to make the combustion completely combustion, because the fuel which is used to be completely burned. So we are using compressed air. Okay. So what is the component required for compressing the air? Air compressor. Very good. We need an air compressor. So what is the source of energy for an air compressor? To run a compressor we need a separate energy. But here what we are doing here is, this air compressor is coupled with the turbine. So what the power source is generated is used to run the air compressor. So that atmospheric air is taken inside, compressed and it is sprayed. So definitely it will increase the efficiency. For normally, instead of supplying the atmospheric air, we are taking the atmospheric air, we are compressing and we are sending inside. So this compressed air will makes the burning efficiently in the combustion chamber, so therefore the efficiency will be increased. Okay, so that is why this compressed air is there. Now see this, this is circuit. See here, three different. This pink color is the steam, and blue color is the water, and this orange color is the fluid burned gases. Okay, see here. Here water comes here, here also water, here this dotted lines is about the steam, okay, and this is water, feed water. So initially water is coming to the feed water to the economizer, and then coming to the water circulating pump like this is then circuit. This fluid gas goes outside, is getting heated and goes to the prime mover, and some amount of heat is coming outside to run the gas turbine like this, these are the. So now from here, what you have understood that we are using a compressor, some amount of energy which is produced here is used to run the compressor to send the compressed air. Okay. So this is our case study. By implementing this air compressor and economizers and these convective separators, the efficiency of the boilers can be